Welcome. This is going to be a new series on, call it casual game mechanics or hyper casual game mechanics. We're going to start with the resizing mechanic, and then I'm not quite sure how many videos. We're probably looking at about 10 videos in total. So let's just get started. So I need to kind of make a little scene to test stuff in. I'm just going to use standard Unity geometry. So this cube is going to be the player, I would say. So I'm just going to reset its position. Let's just rename it to player. And I'm going to create a new empty game object just to place all my level assets. So let's just call that level assets. And we're going to add a plane for the ground. Not a quad. Actually, we can technically use a quad. Yeah, we can. Okay, so I'm just going to rotate this quad. Scale it up accordingly. So I'm going to scale it up the amount that I think the level. We're not going to be doing any procedural generation at this point. So I want to just kind of get things going. So I just want to have a level where later on we can talk about procedural generation. So I'm going to make it about 30 units long and about 5 units across. And just reposition the X over here. And then we'll just shift it along to kind of where the player is over here. Wrong direction. Let's go this way. There we go. Okay, so this is our little testing ground, testing area. So we're just going to rename this to floor. Let's make sure it's got a collider. It does. Okay, so we're good to go. So it's got a collider. It's got the. I'm just going to move the character up. Now I'm going to be scaling this character up and down. So I want to reorientate its pivot or its origin to be on the floor and then move the geometry up. So I'm going to select, create a new empty object. Reset it to be at 0, 0, 0. Let's just call this player base. I'm going to grab the player and just parent that there, and then just move it up by 0.5. Should put it on the ground. Yes. So we're going to be scaling this, so it scales from the ground. So we don't have to do any weird kind of repositioning, like scale it up, reposition, scale it up, reposition. This way it scales from the correct origin. So obviously if you're doing something like this in Blender, you just make sure the origin is in the correct place to start with. Okay, so let's create some materials. Just standard materials should be good, just so we can kind of add a little bit of life to the scene. I'm just going to create, let's call this one player. Let's make it blue. There we go, and then we're going to create another one. Call this one floor. Just change that to make it, I don't know, maybe an orangey color should be good. And then the last one is just for any obstacles we're going to hit. So I'm just going to create this one and call it obstacle. Then we'll just use this when the time comes. I'll make the obstacles maybe I don't know, a green color. So you'll notice the lighting looks a little bit crap if you're using your standard Unity before using URP or HDRP. So let's just go and say auto generate lighting so that it can bake it and bring some GI into the scene and bring some ambient color into the scene. This intensity multiplier over here. So you'll notice I can make it lighter or bright, darker based on that. Okay, I'm also just going to remove mixed lighting, just make it all real-time lighting completely. So I'm going to change this light to be real-time. I just want everything to be real-time, so I don't have to worry at a later stage whether or not to bake anything. Okay, so now we are pretty much good to go as far as the level. So now we need to add some assets or some level objects we can crash into, bump into, that sort of thing. So let's start with a cube. Because for this resizing one, I was influenced by, actually can't remember the name of the game. I think it's something jelly. Let me just put this off camera in case of any copyright stuff. I'll just mention what the game is called. Okay, I gotta go look for the reference here. Still looking. Apologies for this. Actually, I can't. I will probably share the link in the description just so you can take a look at it. But we will, I will, it's essentially you're going to scale this object to fit through tight spaces, then squash it down to get it underneath other spaces so that you can actually control the object. So we're going to create an obstacle here that we can change to have a tall, thin version and a short, squat version. Okay, so I'm just going to zero that out, put that at like 0.5 so it's on the ground, and zero that out again. And then basing it on the actual size of the object. So I'm going to use my snapping so that I can get it correct. Wow, my brain today is tired. Where's my snap tools? There we go. So I'm going to make it snap like half a meter. I think should be fine. I'm going to hold down control and snap it over. No, I think we need to actually make it back to 0.25 again. I think that'll be a good amount. So we're going to go for 0.25. And we just snap that across. Duplicate that mesh and snap it across to the other side, so it's going to be that thin and it's going to need to go through that size object. Then we're just going to select these two cubes and make them 2 meters in height and just shift them up in the Y by that amount. So that'll be our first obstacle that we need to get through. And then we're just going to add a little, let's call it a roof, or like a little object that we want to put across the top. So I want to zero that out so it's in the middle of the two objects. We're going to move it up by 2 so it's correctly placed. Then we're just going to scale it down to kind of gauge whereabouts. Let's see. Yeah, I think 0.2 should be good. And then we need to scale it across, so I'm going to kind of eyeball it and then see what the closest value should be. So it should be like 2.5. And all I need to do is just vertex snap that, holding down V to that object. There we go. Then we're just going to grab all of these and put them into an empty game object, which is going to be at the center of that. So I'm going to grab all of these, parent that there, so that we can just move this object around. And all we're going to do is just scale this up and down to kind of give us, or not technically scale it up, but let's see this. Let's call this tall obstacle. Then we're just going to duplicate this to make a thin version, short obstacle. Just going to move this across, and we're just going to make this one shorter. So the current character is 1 meter, 1 meter, 1 meter. So these ones, to get him to squat underneath, is going to be like 0.5 in height. Same with that one, we're going to make that one 0.5 in height. And reposition these two to be 0.25 above the ground, because that'll put it on the floor. Then we're just going to, again, just hold down the vertex and snap it down to the bottom. We're also going to make this one a little bit wider. I think it just needs so that the character can get a little bit thin and squat. There we go. Then we'll just scale this up again to kind of eyeball it. And once we know where we kind of roughly where it's supposed to be, it looks about right for. Okay, so let's just assign materials to these objects, and then we'll start using these objects as they are. And we probably, as we progress with this, you're probably going to want to make these into prefab, so we probably should just do that now while we add it. Okay, so I'm going to create a prefab folder here, because when you want to instantiate them, you're just going to want to have a folder with these objects as prefabs. But before we do that, I'm going to want to create a collider in the middle here, so that when we go through the collider, we can add some score. So that's what we're going to do here. We're going to grab this box here, we're going to duplicate that and just rename this score counter. I'm going to make sure that this gets zeroed out to the middle here, and I think it needs to be like 0.5 in width. And all we're going to do is turn isTrigger on in that, and we're just going to disable the mesh renderer just so that we can have this little box collider. If we're going to wireframe, you'll probably see it a little bit better. There we go, there it is. So that's going to be our score counter. So we're going to do the same thing for this one, then we're going to start adding some tags. So I've just duplicated this one. Let's call this one score counter. We're going to be adding the same, like we're going to be adding some logic that will acknowledge or recognize the score counter. So let's see. Yeah, looks looks about right. 2 meters. It's also is trigger needs to be turned on to this box. And now turn off the mesh render so we can't see it. And we're going to add some tags. So I'm going to create a tag over here. Let's call this obstacle, and let's create another one called score. We're going to assign the obstacles to the obstacles. I'm going to assign the score to the score. Apologies if you can hear that hammering in the background. Okay, so let's get going. We got all the stuff we need. We got the obstacles, and they have their colliders. We have these ones. So I'm just going to start kind of just duplicating them around a little bit using the snap tool, so that it can just snap every 25 meters or so. I feel like this one and this one are a little bit far, so we're going to leave it at that. I think that's all we need for testing. We don't need much more than that. So what the idea is that we're going to make this object constantly, as in casual games, take away one of the controls, so make the object constantly move in this direction, and whenever it successfully gets through one of these areas, we're going to add score, but every time it collides with one, we're going to get it to restart the level. So that is, and we're going to do this both in Bolt and C# as usual. We're going to do both of them. So we're going to start with, we'll start with C# and then move on to Bolt. So just for testing, I'm going to rename this scene to be Swerving Mechanic, and we're just going to put in brackets Bolt. I'm going to reload it, and all I'm going to do is just duplicate that scene and just call this one code, just so that we have the two. So let's, like I said, we're going to start with the code one. Also just going to move this view up here, so it's a little bit, because when I get the flow machine down here, I'm going to need to take a look at the code. Okay, so let's start kind of by repositioning the camera quickly. The camera should be somewhere where we can actually see what's coming up. Like this, you can't see it, so I think I'm going to kind of go at a bit of an angle. I'm going to select my camera, go to Game Object, and say Align with View. Might be too much, so let's just move in a touch more, kind of like that. And say Align with View. There we go. Okay. I think that'll do it. So let's select the player and let's get going. So the player is going to need a rigid body on there just to calculate the collisions, but we're going to make it is kinematic, so it's not going to get affected by any of the gravity or any of the forces. It's just going to be using the rigid body at the end of the day just for collision detection. So we set that, and we're going to go and create a folder. We're going to call this scripts, and in the script here we're just going to add a script, and we're going to call this after the mechanics. So in this case I'm going to call this Resizing controller. There we go, just waiting for it to recompile. Okay, I'm going to select the player, and I'm going to assign the script. You can either drag it onto the viewport, drag it into the character in the hierarchy, or just drag it onto the actual inspector. There's 3 different ways you can do that. Okay, so that's good. So let's get it started by getting it moving forward. So let's open up the script. Oh, wait. I'm going to close the Visual Studio Code. So you probably, some of you who've moved on to the latest version of the LTS release 2019.4 will notice maybe that your IntelliSense doesn't work so well in either Visual Studio or Visual Studio Code. The way to fix that is go to Edit at the top, go down to Preferences, select your external tools, make sure you're actually using the correct editor here, and also tick on Load Packages, local packages, and just click on Regenerate Project Files, and then it should be good to go. Now it should open up fine, and you should get, if I'd spelled resize properly, that would have been great. So I'm going to rename. Okay, so I've spelled resize wrong. Let's try that again. Crap, I called it swerving. That's nice. Let's just call this resizing. Controller, and then we'll just rename it. Remember, when you rename the actual mono behavior, you need to rename the script that's associated with to have the same name, so you get rid of any errors. Just quickly go back to Unity and rename swerving to resizing. There we go. I'm just going to select that so I don't have to type it all over again. Do resizing here. It's going to ask me to reload. That's fine because the scene's open in the editor. I seem to have too many of the same script open up here. Okay, so let's get going again. Sorry about that little hiccup. We're going to be good here. Okay, so we're going to need to, we can pretty much get rid of the start. We're just going to be doing, we're not going to be using rigid bodies to move this object around. We're just going to use a standard translate system. So we're going to move the object forward. So we're going to create the variables as we need them. So the first one is going to be a serialized field. It's going to be a float. This is going to be the speed of the character as he travels to the world. I'll set that in the editor, so I'm leaving it blank over here. And in the update, this is where we're going to be doing it. So we're going to be using a built-in function from Unity called translate. So we're going to go transform.translate. And you'll notice if you hover over translate, it's going to tell us that it needs a vector3 translation. So we're going to type in transform. In this case, I want to move it in the characters forward. So transform.forward, we're going to multiply that by speed. Then once again, multiply it by time.delta time just to make sure it's frame independent. And now we can test this. So this is what's going to make the character move. So I'm going to add a comment about this. Move player forward. Okay, let's test this. I'm going to zoom out so you can see it happening here because it's going to quickly leave. Oh wait, it's not going to work. I really should actually assign a speed value to that script. Oh, it's missing the script. Let's assign the script again. Or not. Oh wait, it renamed the damn file. Resizing. Can we? It has its moments where it does weird things like that, or it's just user error really. So let's drag that script again. Now we have a value. So I'm going to put in a default value of 5 for the speed. You're going to need to tweak this based on the game. So there we go. Character is now moving in the same direction. It'll always be a constant speed. Keep progressing forward. It'll never stop moving until we stop the game. So there we go. We got basic forward movement in the code. We're now going to open up the script again. Shouldn't have closed that script. Okay, so now that we have basic forward movement, we are going to do a very basic, when I press a certain button, for example, when I press W, it's going to scale up. When I press S, it's going to scale down. And it's going to be the same thing for your arrow keys and on your gamepad up and down. So I'm going to be using actions as opposed to get key down. So over here, I'm going to go if, and we're just going to say if, and we're going to go input dot get access raw. Just want the raw value. And what are we getting? We're getting the vertical, which is some of you who've done a lot of these tutorials will know vertical is your up and down keys, your W and S key, your up and down arrows, and on your left analog stick of your gamepad is vertical essentially. So what we're saying here is when I press up, because it's going to be greater than 0, we're going to do something. And then if you're in Visual Studio Code, you just need to go Control-Shift-D to duplicate the lines of code that are selected. And in this case, I'm going to go if it's less than. So if it's greater or less than. So over here, we're going to put a comment, scale player up. And this one is going to be scale player down. That's all we're doing in those two. That's all that happens over here. We're going to set an input that is going to allow for the player to scale up and scale down. So we're going to do a little bit of an interpolate or a lerp. So we're going to lerp their scale, so it's not just like jarring, that it goes from this size to that side. We're going to smooth, like lerp that up and down. So I want to add a boolean that's going to check to see if we're currently lerping. So this one's going to be private, and it's going to be a bool. Just going to call that lerping. Okay, so, and we're going to check for it in here, but I don't want to have everything in my update, so I'm going to add a new private void, just a new custom function called, it's called scale lerping. There we go. That should be fine. And you're going to add your 2 round brackets, your 2 curly braces. So this function we are always going to be calling in the update. Essentially, we're just going to pop it in there so that it calls this function every frame, but the actual lerping is going to happen inside of here. So we're going to scroll down a little bit here. Inside of here, we're going to need to have an if statement, because we don't want this event to be firing every single frame unless it needs to. So what are we checking over here? We're going to check if it is lerping at the moment, and we also want to make sure that the standard transform.local scale is not equal to, and we're going to create a new variable here for the scale that we're going to be using. Let's just call this new scale. So we're asking in this here is, are we lerping, and has the scale of the character matched the scale it needs to get to? If it hasn't, then we're going to leave it as it is. We're going to fire off this event. The moment that one of these come back as false, we're going to no longer be able to use that. So at the top here, we're going to make this private. We're going to call this vector 3, and this is going to be new scale. So this is going to be the new scale here that we're going to use. Now, for this basic system, I'm going to manually allow the artist the ability to be able to create their own scaling. So I'm going to call this big scale. I'm going to duplicate that line and make another vector 2, call this small scale. And we're going to be using these 2 variables as we move that line down, so all the privates are together. So big scale is going to be the scale we move up to, small scale is the scale we're going to move down to. And we're going to update that every time we press the button and feed that into the new scale that we're going to be using here. So let's do that before we do the lerp. So new scale, so when you press the button, new scale is going to be equal to, and because this is going bigger, we're just going to create a new vector 3, because we remember we only need the x and the y. The z we don't really want to be adjusting, so we're going to go and say big scale dot x, comma big scale dot y, so we're getting those, and then the position, the scale, the normal scale for the z will just be coming from the actual object. So dot z, we're getting that from the actual object. There we go. So we're now setting the new scale value to match this scale that's coming from the big scale for the x, the y, and then the z we just get from the actual object. We're going to duplicate this line and move it down to the, if it's less than, and we're just going to change big scale, select both of those by going Control D to select these 2. And we're going to go small scale, so it replaces both of them at the same time. And then there we go. So now we've done, oh, one more thing, we need to go and turn lerping to be true here. Actually, do we need that? Actually, I don't think we need the lerping. Let's try it without the lerp. We're going to see as we go. It's just doing a little bit of coding on the fly, so we're going to check that. And then inside here, we're going to actually do the lerping. So we're going to go transform.scale, and it always gives you local scales equal to, and what is it equal to? Vector 3.lerp. And if you hover over the lerp, it requires a starting point and an end point. The starting point is obviously the current scale of the object, and then the new scale is where we want it to go, and then we need one more value at the speed at which it's going to interpolate, or lerp to. So we need to actually create a new variable for that. I'm going to make this again a serialized field so we can control it in the editor. It's going to be a float, and let's call this lerp speed. Again, I'll set that in the editor. So lerp speed is going to be plugged into there. And just to be safe, I'm going to multiply this by time dot delta time. When in doubt, it's always safer just to kind of multiply any value that you're going to be animating over time in the update by time dot delta time. Okay, so this will happen only if that value is true. So let's see. So when we click a button, this scale is no longer, the scale will change and it will no longer match, and then we'll be able to animate this. So we can see if this works just right now. So save it, go back to Unity. Okay. Too many Unities open. I'm going to close this one for the time being. Okay, so let's test if this works. So up and down, your W and S keys should scale up. So scale up. Oh, I did not change any of the scales. So I think we decided that the tall is going to be 2 meters high, and I think 0.5 in width. So 0.5 by 2, and the small scale is going to be 2 across, I think, by 0.5 in height. And the lerp speed, let's make it something like 1 for now. There we go. Notice how it's working. It's lerping really slowly. So if we follow the object, just pause here, and let's make the lerp go a little bit quicker. Let's start that again. Okay. That's working. So now we can just tweak the lerp speed values to be what we need it to be. Select the player. Let's make it something like... Remember, you are multiplying this value by time. There we go. That's really quick. Oops, I tweaked a value I shouldn't have tweaked. Where was it? 0.5, 0.5 and 2, 2 and 0.5. Okay, so the problem with my logic here is I'm going to grab this at the start of the game, at the wake. We have to go and say new scale is equal to transform dot local scale, and that's it. So what's happening is it's taking the default values of the new scale, which is 0, 0, 0, and that's why we were having that 0 issue in these two values here. So this should now resolve that issue. Okay, so there we go. So this is going to work, and again, this is only going to fire off when the two don't match, when the scales don't match. So once it's reached the scale it's supposed to be based on the new scale, then it's going to be fine. It's not going to require you to go and worry about that being firing every single frame, because it will not fire every single frame. It'll be locked off. There we go. Okay, there we go. That's it. So now we can, now that we have something moving, we can actually, I'm just going to get the camera to do a simple follow, and then we can start doing some score counting. But I first want to quickly scale this object's collider. I know that when we scale it's going to fit, but it's just going to fit. So I just want to edit the box collider. So it's a little bit smaller than the geometry. So like 0.95, 0.95, 0.95. We edit the collider so we can see it. It's just inside the geometry. I think that should be allowed to get through safely without hitting any kind of weird collision events. Okay, so I'm going to, like I said, we're going to quickly make a script that we'll use across the board. So we're going to create a script here that we can adjust as the series progresses. Let's just call this camera follow controller. And like we can add some support for multiple situations that this camera could go onto. So I'm going to grab the camera and I'm going to assign the script onto the camera. We're going to open up the camera script here. Pretty much this is done. The scaling, the whole system there is done, so we're good. So we're going to be updating the camera just in the update. We are going to need two things. Actually, we're not going to do any lerping for the camera. It's just going to be constant follow hard. So we need to have a private variable that's going to be referencing the transform of the player to find where the player is. And then the second one is also going to be a private variable. It's going to be a vector 3, and this is going to be the camera offset. just so we know the offset from the object from the player, and just accommodate for that offset. So on the awake, we are going to have to do two things. We're going to have to assign the player ref is equal to, and we're going to find the object by type, and the script on the characters there. So we're going to say resizing controller dot transform. So we can get the transform of the object that this resizing controller is on, and then the camera offset is going to be equal to this object, so transform dot position. So now that we know where the camera is when it starts, and we know where the player is when it's we can essentially tell this object to transform dot position is equal to, what is it equal to? It is equal to a new, actually technically just go to transform dot position plus not transform dot, what am I saying? Player ref dot position plus camera offset. Okay, so that should now make the camera follow the player with the camera as initial offset value. Okay, so again, let's test this out, see if it works. So the camera's over here. We probably should just move the camera up a little bit, and probably move it a little bit closer, so let's just, so we don't see too much of the level, and the rotation might be a bit much, so let's tweak the rotation here. -40 and make this one 0. Let's just see what that looks like. Okay, so let's suss out if this works. There we go. The camera is now following the player. There we go. And that's it. That's as basic and as simple as you can get. So now we need to calculate this. So every time the player goes through here, we want to add to the player's score counter. But I just want to turn off this background. I want to keep it very like mobile-esque kind of background. So I'm going to go to the camera. I'm going to turn off the skybox, choose a solid color. Let's just make it a kind of a dark kind of gray for the background. Just kind of give it nice, minimal, simple. You could probably even put in a gradient there. Upgrade to something like the universal render pipeline and allow yourself to kind of create some really cool stuff. But for the time being, I think that should be fine. So now all I need to go in and create a UI text. I'm going to go to my canvas so you can see it. There's my canvas. I'm going to make sure that my canvas scales with screen size. So under constant scaler, change scale with screen size so it can change dynamically based on whether the screen gets smaller or bigger. I'm going to make this to 1920 by 1080, so the resolution, HD resolution. And then I'm going to just grab this little text and I'm going to move it to the top left, I think. So the way I'm going to do that is I'm going to hold down Control and left click in the bottom, top left. You'll see that the object automatically pops to the top here. Okay, so now we just need to scale that text. I'm also going to tell the text to where it says vertical, I'm going to tell it to overflow so that the text can overflow, and the same thing horizontal, so that I can make the text bigger without having to make the holding shape bigger. And let's just make this white for now. Or maybe the color of this orange. There we go. I'm also just going to make it bold and italic. There we go. And just kind of move it in a little bit. We're just, like I said, we're just using this for reference to calculate the amount of the score that we have. And then just for safety's sake, I'm just going to make that 70 and just put that as 0 by default. Okay, so we probably want to rename that text to score text. Okay, so normally you're going to want to run some sort of UI and have some sort of UI script here. For this exercise, I'm going to just... Actually, no, I'm going to create a UI script. So over here, we're going to right-click, create script. Let's call this UI manager, and because it's the canvas is where the UI is going to be managed, I'm just going to drag the script directly onto the canvas, and we're going to create a function that we're going to call from the player to the actual UI manager. There we go. Open up the script, and we don't need any of this. We're going to create a public void, it's called update UI score. Let's just call it that. Whoops, that should not have been inside the round brackets, should have been outside the curly braces. I'm going to feed through, actually we don't know, we don't need to feed through, it's one every time we can change that score value. So we're going to create a variable here, just needs to be private, it's going to be an integer, I want to keep it whole numbers, and let's call this a score total. And in the score total here, we're just going to go score total plus plus. Can we do the plus plus properly this time? So score total plus plus. So we just add to the score, and then we're going to need a reference, obviously a reference here. So I'm going to, this one I'm just going to make it a serialized field. So because it's part of the child, I can just drag this in. And this is going to be a text, but you'll notice you have no access to text. That's because we don't have the namespace at the top here. So we're going to go using Unity Engine .ui, and the moment you do that, text will be fine. So we're just going to say score text UI. Okay, so once we update the score, we're going to want to update the UI with that. So it's score text UI dot text is equal to score total dot toString, because remember we have to convert it to a string because UI only deals with strings. And that's pretty much it. So I'm going to do this, I want to update this score at the start just in case we don't it doesn't work straight away, like if you have some random text inside of that holding like the actual text bubble. So here we're just going to say score text.ui is equal to whatever this current score is. In this case it's going to be 0. So we're going to update this function every single time, and we should be able to just go static you can't do that, so we're going to not do that. Okay, and then all that's left to do is I'm going to make this a public static, call it the name of the actual script that we're in, and we're just going to call this UI man. Okay, so we're making a reference to the script, and in the awake we're going to say the UI man is equal to this. Okay, so now we're going to fire off this code from the player every time we overlap or collide something. So the work on this side is pretty much done. So over here we're going to do an on trigger enter, and we're going to check to see if the object that we're triggering with, so if other dot compare tag, what do we call it actually? Can't remember. Let's just see what we actually call this object. Grab one of these obstacles, grab the score, we called it score. So every time we go through and if we hit score, we're just going to fire off and call the UI manager dot UI man dot, should be an update UI score. There we go. Okay, so we have reference to the manager. We're telling it to update the score every time we overlap one of these objects. So when we enter that trigger. So we can test this as it stands and see if it works. Okay, let me show you what I did in the beginning where we set the text to be what the score is, because if we go to our score text here and we leave it at 100, for example, and we start the game, it's going to say 100. But why did it actually say 100? It didn't update properly. Oh, stupid. Okay, so let's try that again. So I'm going to grab the score text and assign it to the score text UI. And you'll see that there's 100, so if I push play, it's going to go and show, it's going to reflect 0. Okay, so something we haven't added yet, might as well do it now just to see if the on collision is working. I'm going to do an on collision enter, And we're going to do the same thing. We're going to do an other. So if we're going to go if other dot game object dot compare tag, and it's going to be this one's going to be obstacle. So if it hits an obstacle, all we're going to do right now is just we're going to load the scene. But again, just like we did with the text, scene manager needs to be added at the top here. So we're going to type in using Unity engine dot scene management. So we can go down here, we can go and say load scene. Sorry, scene manager dot load scene. And what scene do we want to load? I want to load the current scene, the one that we're in. So I'm going to, inside here, I'm going to go and say scene manager dot get active scene dot, and we're going to look for build settings. So you can see, just type in build. Sorry, you have to put the 2 round braces dot build index, and that should do it. So we're getting the active scene and we're going to load that. So let's see if that actually works. If that works, then we know that at least. Why is it? That's weird. As you noticed, when we turned is kinematic off, it works just fine. Well, then I'm turning off use gravity and I'm locking all of this stuff. It should still be fine. Then we'll say is kinematic is good, and let's test this one more time to see if it restarts. Okay, so my collider is still a little bit big, so I'm going to kind of shrink the player collider a little bit just so we can get in there. So I think we had it at 0.95. Let's go like 10% smaller than the original size. So let's see if that's enough. Oh, sorry, I made this game and I can't even play it. Okay, I'm going to go step by step so I can see why it refuses to go inside there. Looks good. Shouldn't collide with it unless this collider is doing something weird. Oh no, there we go. Now it goes through just fine. So it must have been just like off by a fraction. There we go. So now let's test it one more time to make sure everything is working. But we now have a fully functioning resizing mechanic game. So sorry, that shouldn't have taken this long. So apologies. I hope you've learned something. I hope you've enjoyed it. Keep supporting the channel, and I'll keep getting better at making these videos. Let's see. I'll see you in the next one where we're going to be doing swerving mechanics. So see you then. Cheers, guys. Be safe.